Welcome to Mathematics, guys. This is our third episode, and today we're going to be learning about derivatives. All right, first we'll learn about the definition of derivatives in terms of limits. This is pretty simple. What you have to ask for yourself first is, what are derivatives? Or differentiation, right? It's pretty much a rate of change, right? For example, if you have a distance versus a time graph, right? Whatever the rate of change is of that will give you speed, right? Was the same thing. This is about finding the rate of change at a specific point. Not all graphs are going to be linear, and where your slope would equal to the tangent line anywhere, any one point on the graph, right? For example, let's look at when f of x equals x squared. All right, so let's graph this. So we know, so let's say it goes something like this. Okay, that's f of x equals x squared. All right, if we wanted to find slope at one single point, because that's what's happening, that's the rate of change, right? At one point, how would we find that? That is the derivatives. How do we find slope of at one point? Let's say if this point was called x naught. All right, so in this case, this thing right here, this would be f of x naught, right? And then we, at a certain distance, we had right here, we had x naught plus h. Okay, and then we had f of x naught plus h. Okay, so distance here you're traveling is h amount. If we were to find slope between this and this, this is the first line you think of, right? Like, this is what usually people think about when it comes to average rate of change. From this point to this point will give you average rate of change. But we want the instantaneous rate of change, which is just at this point. How would we define that? Right? If you remember, so what is slope? It's just rise over run, right? In this case, it would just be f of x naught plus h, right, minus f of x naught over h, right? Because that's how much it's changing by. Or you could even say x naught plus h minus x naught. Well, this cancel out, you're left with h, right? That's our slope. But if you knew what h was, if h was a certain distance, right, that will give us the rate of change, an average rate of change. But we don't want that. We want at an instantaneous point. What is the rate of change at this one point? So let's see. Let me draw that in different color. So we want like a tangent line, the slope of a tangent line that's only going to be touching that one single point, right? We want the slope of that. All right. How would we find that? Well, it's simple, right? What should h be if we want to find that one single point? H should equal 0, right? Because if h equals 0, then x naught is equal to x naught plus h. But how would we show that? If you know about limits, it's simple. So in that case, the slope will be equal to limit of h approaching 0. All right, we want the h to approach 0 to give us the instantaneous velocity or instantaneous rate of change, right? Would be f of x naught plus h, all right? So at this point, minus f of x naught over h, okay, as h approaches 0. So in this case, all you have to do is, so if you have an example right here, f of x squared, you just plug it in, right? So that would, you solve it. Limit as h approaches 0, right, of x naught plus h square minus x naught square over h. You expand that, so limit of h approaching 0, sorry, here, and it's equal to x naught square plus 2x naught h plus h square minus x naught square over h. All right, well, this and that cancels out, right? And this and this cancels out, and this cancels out. So you're left with limit as h approaches 0 is oh, you don't, there's not even, there's nothing in the denominator, so it's just 2x naught plus h, right? And you substitute that in when you, which is equal to just 2x naught, and that is a rate of change. So whatever the x naught is, it could be any value. It could be any value, and it will give you what the slope is at that point. So say, well, let's say if x naught was equal to 4, for example. All right. So in this case, f of x is equal to 4 squared, which is what, 8. All right. But what is the derivative f of prime x equal to? Right. We know the f prime of x is equal to 2x. And you plug that in, 2 times 4. Sorry, that should be 16. Wow, my math. Sorry, guys. That should be 16. 2 times 4, which is equal to 8. Right? So this is what the rate of change is at that one single point. All right? And this is basically the simplest explanation of what derivatives are. You're trying to find what the instantaneous change is, how the graph is changing. Okay, if it's distance, which is time, what, like how the speed is affected, or instantaneous speed, right? If it's a speed versus time, the instantaneous acceleration. That's what derivatives are. And this is the limit definition of a derivative. Okay, it's pretty simple. And in the next episode, we'll be going through other method of finding derivatives, the simpler method, the faster method. But you must know what it is before we go into that. So this is the simplest definition of that. If you like the video, please subscribe, leave a like, and leave a comment. And until then, take care.